Guys, welcome. So today we are going to look at the question drunk passenger from the Green Book. So this is a very interesting problem, and if you have been through the problem and read the solution, and if you had difficulty understanding the solution which is given here, then don't worry, you are not alone. So let me go through the question and try to explain the reasoning and try to convince you of the solution. So the question states a line of 100 airline passengers are waiting to board a plane. They each hold a ticket to one of the 100 seats on that flight. For convenience, let's say that nth passenger in line has a ticket for the seat number n. So the first passenger has a ticket for seat number 1 and so on and so forth. Being drunk, the first person in line picks a random seat, equally likely to be each seat. All of the other passengers are sober and will go to their proper seats unless it is already occupied. In that case, in the case when it is occupied, they will randomly choose a free seat. You are person number 100. What is the probability that you end up in your seat? That is the seat number 100. So there is a hint also given here, and I think the hint is more useful here than the solution. So we'll follow the hint, and I think that is the proper approach to follow this question. So as I cover these questions in my videos, so for each question, like there are multiple solutions possible. So I am not going to go into all the possible solutions. I'll try to explain the solution which I feel is the most easier to understand or more easier to grasp. Okay. So let's imagine the scenario when there are only two passengers. So there are two passengers. So in the airplane, there are two seats, seat number 1 and seat number 2. Now, the drunk passenger, which is P1, so P1 being drunk can either choose the seat number 1 or seat number 2. So in case P1 goes with seat number 1, then me as a passenger, so in this case, in the case of two passengers, I am the passenger number 2. So I'll go to seat number 2, which is my correct seat. This is the scenario 1. So in my sample space, there are only two scenarios possible. One scenario is when the passenger 1 goes to seat number 1, then I will have only seat number 2 left to me and I'll go to my own seat. In the scenario 2 is when the passenger 1 is drunk and being drunk, he goes to seat number 2. So in this case, I have no other option left. So as it is stated in the question that in case when there is no option, then whatever is remaining, that person will go and sit there. So in this case, since the seat number 2 is already taken, so I as a passenger 2 will go to seat number 1. So if someone had asked you, like in case of two passengers, what will be the answer? So it is simple. The probability of me sitting on my own seat, that is seat number 2, is scenario 1, and the probability of scenario 1 is half, because the probability that the drunk passenger chooses either seat number 1 or 2 is half, as it is mentioned that the being drunk, the first passenger in line picks a random seat and each seat is equally likely to be picked. Okay, now let's take the scenario for three passengers. Let's see what happens in the case of three passengers. In case of three passengers, there are three seats, seat number 1, seat number 2 and seat number 3. So here there are three scenarios. So in the first scenario, the passenger 1, which is the drunk passenger, he picks his own seat, which is seat number 1. So in this case, when the passenger 1 picks this seat, then the passenger 2 is not drunk, only passenger 1 is drunk. So when passenger 2 comes, he sees that his seat is vacant. So he will go and he'll sit on his seat. So what this leads is that me being passenger 3, I'll get my own seat and I'm happy. Scenario 2 is when passenger 1 goes and sits on my seat, that is seat number 3. In this case again, passenger 2 will come, he'll see that his seat is vacant, so he'll just go and sit on seat 2, and me as a result will have to go, I am passenger 3, I'll have to go and sit on seat number 1. So here I am sitting on incorrect seat because the drunk passenger is sitting on my seat. Okay. Now scenario 3 is when passenger 1 goes and sits on seat number 2. So this is a unique case. Now what happens when passenger 1 is sitting at seat number 2, and when passenger 2 arrives, now passenger 2 is not drunk, so he will go and try to first find his own seat, and he'll find that on seat number 2 the drunk passenger is sitting. So now passenger 2 has two options between seat number 1 and seat number 3. Now passenger 2, he can either pick 1 or he can pick 3, and his chances of picking 1 and 3 would be equal, because as given two seats, it is stated that the both seats are equally likely to be picked by any passenger. So the passenger 2 is either going to pick 1 or 3. So let's take both scenarios. In case the passenger 2 picks seat number 1, then uh, I am passenger 3, I'll get to sit on my own seat. Okay. And in case passenger 2 goes and sits on my seat, then I as a passenger 3 will have no other option but will have to sit on seat number 1. Okay, so these are the only two scenarios. So as we have covered all three scenarios, let's try to find the probability that passenger 3, that is me, is sitting on seat number 3. So in scenario 1, we see that if passenger 1, the drunk passenger, goes and sits on his own seat, then scenario 1 is the one which covers where I am sitting on my seat. The scenario 2 is when the passenger 1 goes and sits on my seat. So this simply won't cover my scenario, because if someone is sitting on my seat, no matter where, like whatever combination you make, I won't be sitting on my seat. In the scenario 3, so scenario 3 is being split into two scenarios, because now the passenger 2 has the option of choosing between the two seats which are available. So in this case, if you see, there is this one scenario between the two split scenario in which I am going to sit on my own seat, and the other scenario is which when I am not going to sit on my own seat. So if we calculate the probability, then for scenario 1, the probability that passenger 1 chooses seat number 1, and the remaining 2 and 3, seeing that their seats are vacant, they are going to sit on their own seat only. So only for P1 we have to calculate the probability, so that would be 1 by 3. Scenario 2 is not meaningful to us, so because in this case, no matter what happens, I'm not going to sit on my own seat. In scenario 3, we say that the passenger 1 is going to pick seat number 2, so he'll pick seat number 2 with a 1/3 probability, and we are saying that passenger 2 now has an option between 1 and 3, and when he picks 1, I'm going to sit on my own seat. So passenger 2 picking seat number 1 has a probability of half, because he has two options. So it is 1 by 3 plus 1 by 6, which will result out to be 1 by 2. So similarly, we can calculate for 4 passengers and 5 passengers and n passengers. The point which we have to understand here is that in case, so no matter how many number of seats there are, so let me draw the picture of n seats. So this is seat number 1, then seat number 2, until here, let's say this is seat number n minus 1, and this is seat number n. So the drunk passenger, he can either come and, so let's name him drunk passenger. Okay, the drunk passenger, he'll either sit on seat number 1, in which case everyone else is going to sit on their own seat and I'm going to get my own seat, or he comes and sits on my seat, and in that case, no matter what happens, no matter where everyone else is sitting, I am not going to get my own seat. And the other scenario is when the drunk passenger chooses a seat between 2 and n minus 1. In that case, whichever seats he pick, that guy is now going to become a new drunk passenger. So in case of three passengers, in the scenario 3, since the passenger 1, the drunk passenger, chose seat number 2, so the guy who was going to sit on seat number 2, that is passenger 2, has now become the new drunk passenger, and now he has to make a choice between seat number 1 or seat number 3. Similarly, in case of n seats, again, like let's say the drunk passenger chooses someone here, seat number 7. So the seat which was corresponding to this passenger P7. Now this P7 guy is going to become a drunk passenger, and now he has an option to choose, because his seat is not vacant, so he has an option to choose to either go to seat number 1, which was of the original drunk passenger, or choose a completely different seat, like whichever is remaining. So what will happen is, and similarly, if let's say if P7, the new drunk passenger, chooses seat number 1, then it is guaranteed that I am going to get my own seat. Because what will happen is, let me try to explain you with four passenger. So 1, 2, 3, and 4. So the point I'm going to drive is, I'm saying that the passenger 1 goes and sits here on seat number 2. Now passenger 2 is the new drunk passenger. So I'm saying that if passenger 2 chooses seat number 1, if here like the passenger 7 chose seat number 1, so here in case of 4 seats, if passenger 2 chooses seat number 1, then it is guaranteed that I am going to get my own seat. How is that possible? Because like after this passenger, whoever comes, they are going to find their own seats vacant and they will sit on their seat. So my seat is guaranteed to remain vacant when I come. So therefore, if the passenger which has now become the new drunk passenger, if he chooses the original drunk passenger seats, then I am going to get my own seat. Now, what is the other scenario? Other scenario is when P7, like the new drunk passenger, chooses a seat which is not equal to the seat number 1 or the original drunk passenger seat. So in that case, a cycle will form, because now let's say the P7 chose and went and sat on seat number 23. Now the new drunk guy is P23. Now again P23 has two options. So if either he goes and sits on P7, the original drunk passenger seats, or he goes and sit somewhere else. So either P23 can go and sit on seat number 1. So in this case again it is guaranteed that I'll get my seat N, as I explained here, or he sits on some other seat. Then again let's say he sits on P30 on seat number 37. So now this 37 passenger, now this person has become the drunk passenger, and this cycle will keep on continuing, and this cycle will close only when the last guy, when the cycle is closing, that guy, let's say the last cycle guy, he is going to have two options. He has an option either to sit on seat number 1, where the original drunk passenger seat was there, or he can sit on my seat. Just take a pause and try to understand what I'm saying. And I'm saying that the cycle which is forming here, that the original drunk passenger sits on some other seat and that person now becomes a drunk passenger, and then that passenger is going to go and sit on some other seat, and similarly you see the cycle is forming. And I'm saying that this cycle will end only when that the last drunk guy, or the last newly drunk guy, is going to sit either on the seat number 1, which is the original seat, or on my seat, which is the seat number N. And what is the probability of that last guy sitting either on seat number 1 or on my seat? So when the cycle ends, what we are saying is that what is the probability that he picks seat number 1 or the seat number N, which is my seat. So we can say that this probability is same as the probability of the original drunk guy either picking seat number 1 or seat number 100. 100, here we have 100 seats, 100. So what is the probability of the drunk guy either picking seat number 1 or the seat number 100? So it is simply half. Okay. So this question is independent of the n value. If n is 100 or 10 or 1000, the answer is going to come half only. So I hope you understood the solution, and if not, leave a comment, and if there is any point where you think that you need further explanation, do let me know in the comments, and I'll try to explain that point further. Thank you. I'll see you next time with another question.